Hi, my name is Ashi Kathuria, and this is my Physics 2212 Lab 1 report on charged tape. To begin this presentation, I'll go through an overview of the contents. First, I'll run through an introduction, including the purpose and main results, as well as important concepts. I'll go over the actual experiment, the computational model made via GlowScript, as well as some results which come out of that, and I'll end the presentation with some follow-up questions. To be very concise, the main purpose of this lab is to find the amount of excess charge on an ordinary object. These are the main results from the lab, but we'll obviously dive deeper into them later. Before jumping into this lab, it'll be beneficial to review some important relevant concepts, one of which is Coulomb's law. Coulomb's law essentially illustrates the electric force between two charged particles that are a certain distance apart. It's calculated through the formula F equals the Coulomb's constant multiplied by the product of the two charges divided by the squared distance between the particles. Secondly, the electric field is the force created by a charged particle. The units for the electric field is newtons per coulomb and is calculated via the formula E equals the product of the Coulomb's constant and the charge divided by the squared distance. Lastly, more specific to this lab, we'll be analyzing the relationship between the electric field and the force. In this case, the electric force on tape B due to tape A is given by the formula electric force equals the product of the charge of tape B and the electric field of tape A. This is a diagram of the setup of this lab. Here we're holding a charged piece of tape A below tape B, resulting in floating tape. In this lab, the distance between tape A and B is considered the separation distance and is measured to be 2.5 e negative 2 meters. The length and width of tape B are 1.98 e negative 1 meters and 1.8 e negative 2 meters respectively. From there, we're able to calculate the mass of the tape by understanding that clear tape is about 1 gram per meter. Then we're able to calculate the charge of tape B by solving the previously mentioned equations once the separation distance and mass of the tape values are plugged in. According to these calculations, the tape seems to be negatively charged as it repels the negatively charged pen. Here's the GlowScript code, which was generated using the previously discussed values of the dimensions of the tape used, as well as formula previously reviewed. I calculated the magnitude of the gravitational force and electric force, and then used that information in the visual model. The function in the latter half of the code represents the function used to calculate the force between two charged particles on the tape. Here are the data and results from the GlowScript code. This is the visual which comes out of that code, and the data and results which come out are the magnitude of the gravitational force is negative 1.94 e negative 3 newtons. The magnitude of the electric force is 1.94 e 3 newtons, and the magnitude of the charge on the tape is 1.85 e negative 8 coulombs. Some assumptions made through this lab. We believe that air resistance is irrelevant because tape B is static once it floats. We also treated this long piece of tape as though it were a point charge, with all the charge concentrated at the center of the tape. This is exactly what we assumed when calculating the tape's force on one another. We also assumed that each U tape made had about the same amount of charge evenly distributed along the length of the tape. We did assume the charges on each tape were the same. I'll now end this presentation with some follow-up questions. Would these observations be different if the electron charge and proton charges were switched, meaning electrons now had a positive charge and protons had a negative charge? I would believe that essentially nothing would change. Also, why is it important to handle the charged tapes as little as possible, and what happens when the charged tapes come into contact with your hands or other objects? I think that um, they are able to retain their charges because in if in contact with hands or other objects, electrons tend to escape. If in excess or if indeficient, they fabricate due to contact. That concludes this presentation. Thank you.